Okay, taking a look at question number 4 on page 516, it reads, consider the following system of equations. Equation number 1 is 2x plus y plus 6z equals p, and equation number 2 is x plus my plus 3z equals q. A says determine values of m, p, and q such that the two planes are coincident. Are these values unique? Explain. So in order for these planes to be coincident, equation 2 needs to be a multiple of equation 1. So in taking a look at equation 1 and equation 2, it is clear that equation 1 is twice the value of 2 because the coefficient of x in the second equation is 1, and then 2 would be times 2. 3 for the coefficient of z for the second equation, times 2 equals 6. So therefore m must be half of the coefficient of y in equation 1. So therefore m is equal to a half. P must be twice the value of q. So therefore we can come up with an equation p equals 2q, and two numbers that fit this equation are p equals 2 and q equals 1. The value for m is unique, however the values of p and q are arbitrary as p is twice the value of q. For B, it says determine values of m, p, and q such that the two planes are parallel and non-coincident. Are these values unique? Explain. For these two planes to be parallel, the values for the coefficients must be a multiple of the other equation. However, the constant terms must differ by a constant term. So we know that m is going to equal a half because that will make the planes parallel. And for values of p and q, any value of p and q will make these planes parallel and non-coincident as long as p is not 2 times q. Part C says a value of m such that the two planes intersect at right angles. Is this value unique? Explain. So in order for these two planes to intersect at a right angle, their dot product must equal 0. So taking the normals of both planes, we can see that their dot product is 2 plus m plus 18, and when we isolate for m, we get negative 20. So therefore, m must be equal to negative 20, and this value is unique as it is the only value for m that will make these two planes intersect at 90 degrees. Part D says determine values of m, p, and q such that the two planes intersect at right angles. Are these values unique? Explain. Okay, so in order for these two planes to intersect at 90 degrees, we know that the value of m must be negative 20. So this is a unique value. The values of p and q are arbitrary and can be any number. For example, p equals 1 and q equals 1.